Okay, thank you. I'm Miran Choi from Atri, Korea. Okay, so the title is Humans and Computers Converse. The recent explosion of interest concerning ChatGPT shows how important communication between humans and computers is to artificial intelligence as a whole. The development of natural language processing really is leading the AI field, which is to say, leading a true revolution in human life. So we are seeing that Alan Turing basically had it right. When computers can finally hold truly realistic conversations with people, it'll be time to consider them truly intelligent. And this is what is unfolding right now, a lot sooner than we expected. So it's no mystery that Empire is attending seriously to NLP, to conversations between humans and computers. I will present to Empire's initial efforts for that. But the communication goes beyond mere text. Speech conveys all sorts of information beyond just the words. And communication goes beyond only language, extending to face, gestures, and the body. But in this case, shouldn't machine that aspire to intelligent also aspire to human level communication? Then the machine should be expressive too, in speech, face, and the body. And this expressiveness is a job for learning-based programs, in other words, for artificial intelligence. So MPI aims for a modular approach to building AI systems. So in MPI, the artificial intelligence modules are called AIMs, and their configurations for use cases are called AI frameworks or AIFs. I think you've seen already this figure many times. So to be standardized, the AIMs need well-defined inputs and outputs so the blocks can be offered by anybody who respects those specifications. So here's the conversation with emotion architecture based on AIF. It should be usable in most conversation situations. And as you see, the emotional factor is in focus. Okay, let's look at the AIMs that compose it and at their input-output relations. So you see from the user agent, the input speech and videos are fed to speech recognition and video analysis AIMs. And recognized text goes to the language understanding with input text. And the emotion from the text is extracted to fed to the emotion fusion with the emotion from the speech and emotion from the video. And the fused emotion with the text and meaning from the language understanding goes to dialogue processing, AIM. And it produces text with emotion to make the speech synthesis module and produces the output speech with the output emotion. And the output emotion and output speech is used by the lips animation module. And the produced outputs are output speech and output video. So this is the conversation with emotion. And here is the multimodal question answering use case. And this time the focus is on multimodal situations in which humans are discussing objects with the computers. The person should be able to point to things, and the computer should know which things are referred to in questions. Okay, so here you can see the speech recognition again and video analysis. And from the picture, you get the object identifier and recognize text goes to language understanding to find the meaning of inside the sentence and object identifier. And then it goes the question analysis, the AIM, to extract the intention and with a meaning, and the recognize text question answering module will produce the output text. That's the response to the question. And it will be go through the speech synthesis module to output speech. And in addition, it will be output text produced. Okay. So I think I have a demo for that. So okay, I'll show the demo. Okay, can you see the demo screen? Maybe not.
Yes.
Yes. Okay, that's good. Okay, just to show the demo. So this is the demo for the multimodal question answering.
Yeah, it says that MPEG is a format for video compression, and for the last, I'm going to ask, what is an AI? Yeah, it shows an answer about an AI, an artificial intelligence. And the second feature is that you can attach an image from your local folder, and I'm going to attach a file, an image file of an Eiffel Tower. And I'm going to ask, what is the city in this picture?
Milan, but probably we are only seeing the PowerPoint slides.
And for the note, you can see in the
so
log here
you don't
that
see
it says text is Paris. I'm also going to ask
Can you
for the
see it
same
now?
picture that
Yes.
what is the time in this picture? And it correctly identifies that it is a sunset here. And I'm going to attach a photo of a little girl, and I'm going to ask, who is this? It says a little girl, and I'm also going to ask, how many people are there in this picture? And it correctly says 1. And for the last picture, I'm going to attach.
Okay, so far I think it's good. Okay, so that was the multimodal question answering, and the next one is the sorry. Okay, so this is a unidirectional speech translation. So we get to the 3 comprehensions related to speech translation. So the first one is unidirectional speech translation. There are 3 main boxes: speech translation, speech recognition, translation, and speech synthesis. But note that there's also a module planned to extract the speech features here, so that okay, so to extract speech features so that they can use expressively during the final speech synthesis. For example, the input source language may be angry, so the target language translated the speech should sound angry too. So we might also want to make the output voice sound like the input voice, so that you could be heard to speak a language you don't actually know. Okay. But if we can translate the spoken language in one direction, why not 2? So that we can enable a 2-party conversation. So this is the configuration for the bidirectional speech translation. So here we just doubling up on the input and output languages. Okay. And this is the last one is one-to-many speech translation. And we may also enable one person to broadcast in multiple languages. That is one language in, multiple languages out. Okay, so that's the one-to-many speech translation. So moving on from translation, here's a use cases in which a human converses with a computer about a scene, where both the human and scene are on video. So in this case, we need a module to analyze the video scene and extract descriptions of the person and relevant objects. For the person, to understand her expressions, we need information on her face, her gestures, and her body language. And in each case, there's a module for that. Expressive information is fed to module designed to identify the person's so-called personal status. So that's the combination of emotion, cognitive state, and attitude. The personal state information gets fed along with the text resulting from the speech recognition to a language understanding module. In parallel, objects in the scene are identified. That object information along with the person's personal status is fed to a language understanding module, and it results in turn go to the dialogue processing module. But remember, a computer is also taking part in this conversation. So it will be represented as an avatar with its own expressions. So that information too goes into the dialogue processing mix. The final result is the display of the computer's expression with a computer's speech, and the entire scene can be visually rendered as well. Here, so scene rendering, okay, based on the scene description obtained earlier. So this is a complex use case, but just for that reason, it demonstrates that the power of AI modules when combined. And here is also the still visual configuration. So I think it's already seen in the previous presentation. So in which several people are in a video conference, okay, and each with his own avatar. Accompanying them is a virtual secretary here, this time representing not a person, but a computer participant. A special case virtual secretary. So we focus on the conversation between the virtual secretary and the participants. Okay, so this is the slide that shows the modules that make the virtual secretary run. So I think this is already covered in the previous presentation by Jamie. But the secretary's main job is meditation and summarization of the meeting's points. So that output on the right shows that when shows a written summary and her text, voice, and visual representation. Her avatar model may also be useful for other downstream modules, not shown here. Okay, so this is a CAV subsystems, connected autonomous vehicles. So here we focus on the human-CAV interaction. So one module to make it all run. So most are familiar from the busy slides already shown, but notice that some modules have red borders, like this physical object identification, personal status extraction, and personal status display. So they could be exploited to show entire configurations of low-level modules. So those are called composite modules. Okay. So here you can see the interaction through the speech between the human and the car. So there's a command and response. And also there's an output personal status, output text, and finally the machine face, gesture, text, and speech. So we've already mentioned that personal status is cover term for emotion. Okay. All of these can be shown via several modalities through the voice, the face, or the body language. And each modality can be analyzed in terms of descriptors, features like prosody or vocal tension for the voice, arm position for the body language, etc. Okay, so Empire has needs to standardize the treatment of these personal status elements. So we've bravely presented sets of labels for each complete categories and with general and specific adjectives. So I will show the examples. So here is the data structure in which personal status is packages, like emotion, cognitive state, and social attitudes. And here's some examples. Okay, so first some cognitive states. Okay, like arousal, attention, belief, and general adjectives for that, like attentive and specific adjectives. Okay, and some examples of the associated semantic losses of cognitive states. Is also the meaning of each cognitive state presented here. And emotions are treated likewise. So for example, anger, angry, and furious, irritated, frustrated in the last column. And here are the semantic losses for emotion. Social attitudes, the third element of personal status in our proposal standard analysis, is the final levels like this, and the glosses for the social attitudes. So as you expected, there is a special purpose module configuration for extracting personal status from the aforementioned modalities, the voice, speech, the face, and so on. So it extracts personal status from the input text, speech, and some face and body too. And the output of this module is the personal status. And finally, personal status display. This is also explained before, but we can see that from the text and personal status, we can make the composed descriptors and avatar itself, and avatar model. Okay, so and to wrap up this lightning tour, here's a way to display personal status via an avatar. AI-based conversation between people and machines will continue to take the world by storm. We have introduced some of the modules and configurations that Empire Hubs can partly standardize so that each application won't need to reinvent every wheel. And how about the large language models? They will play their parts within many of the modules you've just seen. So thanks for your attention. So if you are more curious, then you can join MPI. Thank you very much.